Lesson 3-4 Integration Geometry, Angles, and Triangles. And in this lesson, you learn to find the complement and supplement of an angle and to find the measure of a third angle of a triangle given the measures of the two angles. Let's take a look at this example in football. On fourth down in football game, the team with the ball usually punts. A punt is a kick in which the ball is dropped by the kicker and is kicked before it hits the ground. Okay, and the longest punt ever kicked in college football game was kicked by Pat Brady of the University of Nevada, Reno, in their 1950 game against Loyola University. The punt was 99 yards long, just 1 yard short of spanning the entire length of the football field. Okay, so in this case, how far a football will travel once it is punted depends not only on the strength of the punter, but also on the angle at which the ball is kicked. If the angle is too small, the punt or the ball will travel close to the ground, okay, then drop. If the angle is too large, the ball will travel high, but not very far. What do you think would be the best angle at which to kick the ball? Okay, so this is your punter right here, and this is what it's talking about. If the angle, okay, is too small, the ball will travel very close, okay, and then will not travel that far. If the angle is not that big, it'll travel farther, okay, compared to, let's say, angle uh, let's say compared to this kind of a punt right here, okay. And when we talk about angle, the symbol for angle will be this one right here. So when you see that symbol, it means angle, okay. And in this case, to be able to find out the best angle, probably the best instrument that we can use for this one, okay, is what we call protractor. So with our protractor, we can measure angles. And if you look at that angle right there, as shown, okay, angle ABC, denoted by the symbol of the angle, and ABC measures 60 degrees. However, ray BC, this is ray BC right here, denoted by an arrow on top, and BC, letters BC at the bottom, intersects the curve of the protractor. There are two readings, 60 degrees and 120 degrees, and always we read from the zero of the protractor. Okay, the measure of angle DBC is 120 degrees. Okay, because if you notice, this ray, okay, begins at zero, and so we read from the outside of this protractor. In the case of angle ABC, this ray right here, okay, hits the inside part of the zero, and that's why we read from the inside part of the protractor. Okay, and what do you notice about angle DBC and angle ABC? Okay, the sum of the measures of their angles is equal to 180. 120 plus 60 will give you 180, which brings us to supplementary angles. Two angles are supplementary if the sum of their measures is 180 degrees. Let's take a look at example number 1, see how this works. The measure of an angle is 3 times the measure of its supplement. Okay, so just like any word problem, we create a let statement. Let x be equal to the lesser measure, and then if that's the case, if it's x is the lesser measure, it's 3 times, okay, it's 3 times the measure of its supplement, so then 3x equals the greater measure. Okay, we simply add the two angles together. X plus 3x equals 180 because the angles are supplementary and because it's asking the measure of its supplement. Okay, assuming that the angles are supplementary with that statement. So you now have 4x equals 180, adding like terms, dividing both sides by 4 to solve for x, end up with x equals 45. So the lesser measure is 45 degrees, okay, and the bigger measure is 3 times x, or 135 degrees, okay, and those are supplementary angles. Okay, next we're going to talk about complementary angles. Complementary angles, two angles are complementary if the sum of their measures is 90 degrees. The backward slant of a face of a golf club head is called a loft. It is designed to drive the ball in the high arc. Assuming that the angle made by the ground and the face of a club is 79 degrees, what is the measure of the loft? So this is the angle made of the club, okay, 79 degrees, and angle X is represented by the loft, and we know that this little square right here indicates a right angle. So a right angle measures 90 degrees. Therefore, this angle right here, 79 degrees, plus X will be equal to 90 degrees. So again, let's do our let statement. Let X be equal to the measure of the loft. Therefore, 79 plus X equals 90. Okay? And then we solve for X. We subtract 79 to both sides of the equation. We end up with X equals 11 degrees. Okay? The club has a loft of 11 degrees. Okay? Finally, let's take a look at example number 3. The measure of an angle is 34 degrees greater than its complement. Find the measure of each angle. Again, just like always, we start with a let statement, and we let X be equal to the lesser measure. Let X plus 34 be the greater measure. Where do you get X plus 34? Because it says here the measure of an angle is 34 greater than its complement. Okay, the other angle will be its complement, which is the X. Add 34, that will be your greater angle. Okay, find the measure of each angle. So in this case, since it's a complement, the sum of these two angles will be equal to, okay, 90 degrees. So you have X plus 34 equals 90 degrees because they're complementary. Simplify this, adding like terms, you have 2x plus 34 equals 90. And then solving for x, okay, solving backward, we subtract 34 to both sides of the equation. Okay, we end up with 2x equals 56, and we simply divide both sides by 2 to undo multiplication, end up with x equals 28. And that is the measure of the lesser measure, the smaller angle, and the greater angle would be 28 plus 34, or simply 62. So the two angles are 28 and 62. Okay, and if you simply add 28 plus 62, that would give you 90 degrees. And those are the two angles, because 28 now plus 62 will be equal to 90 degrees. Okay? Let's take a look at the next concept. A triangle is a polygon with 3 sides and 3 angles. What is the sum of the measures of the angles of a triangle? Okay, we studied this before, and let's review a little bit. Okay, so the sum would be 180. The sum of the angles of a triangle will always be equal to 180 degrees. And when we talk about triangles, there's such a thing, there's a triangle. You can classify a triangle as an equilateral triangle. And in an equilateral triangle, each angle has the same measure. We say that angles are congruent, meaning same measure. So the word congruent means same measure. Okay. The sides of the equilateral triangle are also congruent, meaning the sides have the same measure. What is the measure of each angle of an equilateral triangle? Okay, let's find out. So if we let x be the measure of each angle, therefore if we want to find the measure of each angle of an equilateral triangle, logically it would be adding all the 3 angles, and that should be equal to 180 degrees because of this. Okay, and from there we simplify, that becomes 3x equals 180, and we simply divide both sides by 3, end up with x equals 60. So each angle measures 60 degrees. Okay, another angle that we've studied, okay, another classification of angles, what we call an isosceles triangle. In an isosceles triangle, at least two angles have the same measure. Generally, the two congruent angles are base angles. So in an equilateral triangle, this is how it looks like, where you have three angles that are congruent to each other, all the sides are also congruent to each other. In an isosceles triangle, this is how it looks like. You have your two base angles, which are congruent to each other, and you have two sides which are also congruent to each other. Remember, the hash marks indicate congruency. So this one is congruent to that one. These two angles are congruent to each other. Okay, so that's an isosceles triangle. And let's see example number 4 and see how this works. Okay, it's going to be on the next slide. Okay, so going to the next slide, we have what are the measures of the base angles of an isosceles triangle in which the vertex angles measures 45 degrees. Okay, so when you talk about the vertex angles, when you talk about a triangle, let me give you a triangle. Okay, let's say this is our isosceles triangle. Okay, this is our vertex angle. Okay, so this is our vertex angle. Okay, these are your two base angles right here. We talked about that earlier. So what are the measures of the base angles of an isosceles triangle in which the vertex angle is equal to 45 degrees? So this is equal to 45 degrees. Okay, we need to create a let statement. Just like always, we'll let x be equal to the measure of each base angle because that's what the problem is asking for. Okay, and adding up all the angles, that should be equal to 180 degrees. So you get your two base angles, which is x. Okay, add that to 45, which will give you 180. Okay, so doing that, this is your x. Let me just mark that down for you. This is x, and this is 45. That's the reason why we have x plus 8 plus 45 equals 180 degrees. Adding like terms, you have 2x plus 45 equals 180 degrees. Okay, two-step equation, we subtract 45 to both sides of the equation. You have 2x equals 135 and divide both sides by 2. X equals 135 over 2, or 67 and a half. The base angles each measure 67 and 1/2 degrees. Okay, and finally, let's go to the last example. The measures of the angles of the triangle are as given as x, 2x, and 3x. What are the measures of each angle, and classify the triangle? Okay, before we do that, I think we classified it here at the bottom. Let's see if we did. Nope. Okay, it's probably here. Okay, in classifying a triangle, remember that there are three types of triangles. Okay, we have your right triangle, and the right triangle is equal to, as an angle, one angle which measures 90 degrees. Okay, and there's a good example of a right triangle. Let me find my shapes. For my triangles, here we go. This is a right triangle. Okay, and you have an obtuse triangle, and in an obtuse triangle you have, okay, a triangle where one angle has a measure of more than 90 degrees. So if you get this triangle and we make it obtuse, move the 90 degrees, so that's not going to work. Okay, let me draw a triangle for you then. Okay, so a triangle can be something like this, an obtuse triangle. No, that doesn't work. Yeah. Okay. There you go. Oops, that's not a triangle. There you go. That works. Close enough. Okay, this angle right here is more than 90 degrees, so that's what we call an obtuse triangle. And finally, an acute triangle, this is obtuse. Okay, greater than 90 degrees, one angle. And in an acute triangle, you have something like this. Not that, like this. Something like this. There you go. Where all angles, no, that's a right triangle. Let me do another triangle. Let's make this work now. You have something like this. There you go. This is an acute triangle, okay, where all the angles are less than 90 degrees. Okay, so all of the angles here are less than 90 degrees. Okay, so you have an acute, a right, and obtuse. Okay, pardon the mess. Let's figure out this problem. Measures of the angles of a triangle are given as x, 2x, and 3x. What are the measures of each angle? And classify the triangle. Okay, remember that in letter A, the sum of the measures of all angles is equal to 180 degrees. So if you get the three angles, x, 2x, and 3x, equate that to 180 degrees. You end up with 6x equals 180 degrees, adding the like terms. And solving for x, if we divide both sides by 6, end up with x equals 30. Okay, so the measures of the three angles are 30, 60, and 90 degrees. And if you notice, one angle is 90 degrees, so we can classify this triangle as a right triangle. Okay, so since the triangle is one angle that is measured 90, it is considered to be a right triangle. All right, you've seen my drawing prowess, so forgive me for that. And we've come to the end of our lesson on Google Forms or My Big Campus. Type a summary of what you've learned by responding to the objectives of the lesson, and type a question you may want to ask in class about this lesson. Thank you.